All right, grade 9. So welcome to week 4. We are going to be starting a new unit this week, starting with, it's a geometry unit, which is going to involve unit measurements, enlargements and reductions of figures, scale factor. It's going to involve angles, and it's going to involve transformations of two-dimensional figures. So we're just going to get right into it, and we're going to start with some of the things that we should review regarding ratios and changing units, such as the metric units that we need to change. All right, so we're going to start. I've got this kind of a staircase method, staircase that I want to show you. It's kind of a staircase method for converting kilometers and meters. So some of the main ones that you see there, I'm just going to use my highlighter. So you've got kilometers. If you're using meters, if you're talking like distance, you would go kilometers, meters, centimeters, millimeters. Those are the most common ones that we do use. Now, this could also be for the case of kiloliters or kilograms, or just liters, grams, centigrams, and milligrams, right? So what we're doing there is most of us are pretty familiar with there are 100 centimeters in a meter, or there are 10 millimeters in a centimeter, or that there are 1,000 meters in a kilometer. So what you've got here is actually some of the other ones in the staircase are, because they go down by tens, or they're multiples of 10. So for every 10 millimeters, you have a centimeter. For every 10 centimeters, you have a decimeter. For every 10 decimeters, you have a meter. That's kind of the idea behind it. So two little tricks here, and I'm going to upload these so you can look back on just the note pages if you'd like, or if you'd like to draw these into your own notes, you can do that as well. But going down the staircase, so for every step you take, you're going to be multiplying by 10. Okay? Or you can think about it as moving your decimal to the right. So if I was given 1 meter, I'm going down 2 staircases, 2 steps to get to centimeters. So that means that I'm going to multiply it by 10 and then 10 again. So 10 times 10, I know, is 100, right? So I know that 10 times 10, well, that equals 100. Or 10 times 10 times 10 is equal to 1,000. Okay? And so we do know if we're going down 1, 2, 3 steps from kilometers to meters, you would be multiplying by 1,000. Okay? Now, if we're going the reverse direction, so up the staircase, then you're going to divide by that multiple of 10. So if we were going from meters to millimeters to centimeters, you would divide by 10. But if I was going from centimeters to meters, well, then I would be dividing by 100, because there's 2 steps. Okay? Or if I was going from millimeters to meters, well, that's 1, 2, 3 steps. So then I would be multiplying by 1,000. And if I was going all the way from millimeters all the way up to kilometers, then it would be dividing by, it'd be 1,000,000. Okay? So let's just do a couple quick examples here. And I'm going to put some worksheets, some questions for you to just get some practice. So what is 300 meters in centimeters? So we've got meters, Now I'm going down 2 steps, so 100. So what I'm going to do is just multiply it by 100 or 10 times 10, whatever you prefer. And I'm going to get 30,000 centimeters. All right. Now, when we talk about ratios, so you're going to see this word ratio come up. It's like you have a comparison between two values, but they have to be the same units. So right now I've got this in 5 meters and I have 1 centimeter. So what we're going to do there is we're going to change this 5 meters into centimeters. Which you get 500. Okay, so then as a ratio, we're just going to write it as 1 to 500. And if it's a ratio, then we don't actually, and we're using the same units, you don't need to write your units in. All right, if they had been different units, then yes, you would need to write your units in. But for a ratio, the unit should be the same. So if a map scale tells us that 1 centimeter is equal to 15 kilometers, what is 15 kilometers in centimeters? Write it as a ratio. So we're going to go 15 kilometers all the way to centimeters. So that's 1, 2, 3. Sorry, we'll just move that. 1, 2, 3, 4, 5. Okay, and so what I can do there is I can either go 15 times 10 5 times, or I can be thinking about it as 15. If you've got 5 of these 10s, then it's kind of like saying I just need 5 zeros. So 100,000. Okay, and then I'm going to multiply that together and get 1,500,000. So my ratio is just going to look like 1 to 1,500,000. Okay. Now, when we get into 7.5 meters into centimeters, well, 7.5 times the 100 equals 750 centimeters. Okay, and the very last one there, how many kilometers does 3,750,000 centimeters represent? So if we're going from our centimeters up to the kilometers, then instead of, we're going to be dividing by that 100,000 in this case. So we've got that will equal 37.5 kilometers. So you're going to get some practice on just doing some conversions between the metric system. And I will also upload a answer key later on this week. Okay, the other parts that I do want to talk about here, and just so you can have a clear vision of it later as well, or something that you can follow along with or print, I will put these into the files. So I'm just going to note here, with angles of a triangle, we're going to focus on just triangles for the moment. And so the rule is the 3 angles of a triangle will add up to be 180 degrees. So all 3 angles, they always add up to 180 degrees. So if we're asked to determine an unknown angle, like we are here, if I know that they all have to add up to be 180 degrees, if I figure out what the sum of these two angles is, which is 145, and I take it away from 180, I should get x. So we're going to go x is equal to 180, and sometimes I just go minus 125 minus 20, because that's going to combine those two together to take away. So when I do that, I get 35 degrees. So angle x is equal to 35 degrees. All right, moving it on. This next one here, it has an exterior angle. We call this an exterior angle, and then it has two interior angles, and there would be a third angle in that triangle right here. So one little thing that I should make note of is two angles on a straight line have a sum of also 180 degrees. Okay, so a straight line, you have 180 degrees. So if I know in my triangle that 65 and 45, if I take that away from 180 to find this angle, well, that's equal to 110, so that's going to equal 70 degrees here. But then on a straight line, 180 take away 70, well, that equals 110. So x will equal 110. You may have noticed that x, this exterior angle, is actually equal to the sum of the two interior angles that were not on the same line. Okay, that's a little trick as well. Okay, just gonna go through this one here. And so we've got a bunch of angles given to us, and we are asked to find all of the unknowns. So there's quite a few unknown angles in this one. If we know that two angles on a straight line do add up to be 180, we should be able to find these ones pretty easily. So let's go ahead and do that. So let's start with x. X is going to equal 180 take away 122, which would equal 58. Okay, and V is going to be 180 take away 132. And I get 48 degrees. There we go. And then we've got a few other angles. They're third angles in my triangles. So I do need to calculate them by going y is equal to 43 and 58 taken away from 180. And y will equal 79 degrees. Z is going to be 180 take away 122 and 48. So those two angles. And then I get that is just equal to 10 degrees. And my last one there, W, is going to equal 180 take away 132 and 31. And that would be equal to 17 degrees. So now I have all of the unknown angles solved for in this case. Okay, we're just going to do one more here before we wrap up this video. And just looking at this type of triangle, so you've got equilateral triangles. Equilateral triangles have all three sides equal to each other. And then in equilateral triangles, they all have the same angles. Now, in this type of triangle, this is not an equilateral triangle, but it is what's called an isosceles triangle. So we're just going to say isosceles. Okay? Isosceles triangles mean that there are two sides equal and one side that is not. In the case where you have two equal sides, well, that means these angles are going to be also equal to each other, and these two sides will be equal to each other. So when it says determine the unknown measures of the angles and sides in this triangle ABC, so we often use this notation to show triangles ABC. Let's go ahead and, so the only unknown angle that we still need to find is going to be angle A. Okay, so angle A, or in some cases you could call this angle BAC. And the reason we call it that is just so it's not mixed up with like this half of an angle, right? So it's going to be the full angle. And you always use the angle where the vertex is, or the letter where the vertex is, as your middle. Okay, so either way is fine for me, but just to be a little bit more picky. Okay, so we're gonna go 180, take away 37 twice. And when we do that, we get 106. So this angle up here is 106. And if you wanted to get really technical in each portion, what is the angle? Well, it would be 53, right? It would just cut it in half or divide 106 by 2. Now, we do need to find this length along the bottom. And so we notice that we do have right triangles created here. So we could go ahead and just use Pythagoras theorem. I've got a hypotenuse, I've got a leg. I don't know that leg. So if I wanted to find BD, I'm just going to go 5 squared, because that's my hypotenuse. I'm going to use this variation of the formula. Take away 3 squared. So 25, take away 9, equals 16, and then I square root. So each of these sections is 4. So that tells me that the side BC is equal to 8 centimeters. Okay, so we're going to wrap that up. What you're going to have for an assignment is going to be some converting metric units, and then you are also going to have an assignment sheet on solving angles within triangles. All right, take care.